This video is going to break down how we can calculate the theoretical yield for moles of carbon dioxide. So I'm going to go through how to fill out this row right here. In order to do this, we need to look back at our balanced equation. We notice that within our balanced equation, we have a 1 as a coefficient in front of each of our compounds, meaning that our ratio between any compound is just going to be 1 to 1. This makes thinking through our theoretical yield pretty easy for this specific equation, okay? For these purposes, I'm going to use the abbreviation BS for baking soda and AA for acetic acid, okay? So if I'm going to look at these ratios, I'm going to zoom in on the compounds that I care about. So the compounds that I care about are baking soda and acetic acid. Those are the two reactants that I've been using within my lab. And then I also care about carbon dioxide because that is what I'm actually measuring within my lab. Now, if I look at my coefficients, there's a coefficient of 1 in front of each of those. So I just am going to write a 1 underneath each, representing that I have a 1 to 1 to 1 ratio between these three. Okay, so let's just kind of talk through what this means. If I have 1 mole of baking soda and 1 mole of acetic acid, my theoretical yield for carbon dioxide is going to be 1. If I have 2 moles of baking soda and 2 moles of acetic acid, my theoretical yield for carbon dioxide is going to also be 2. If I have 3 moles of baking soda and 3 moles of acetic acid, my theoretical yield for carbon dioxide is also going to be a 3. Okay, so let's use some numbers that are a little bit goofier than just these 1, 2, and 3. If I had, let's say, 45 moles of a baking soda and 45 moles of acetic acid, my theoretical yield for carbon dioxide would also be 45, okay? If I have 45 moles of baking soda, but I only have 3 moles of acetic acid, this is where I would have a limiting reactant and some excess reactant. So if I'm looking at these two, I would only be able to produce 3 moles of carbon dioxide, okay, because I have a 1 to 1 to 1 ratio. If I had 60 moles of baking soda and 3 moles of acetic acid, I still would only be able to produce 3 moles of carbon dioxide, okay? So you'll notice that whatever the smaller number here is the limiting reactant. So for both of these examples, acetic acid is limiting because that's what is controlling how much product we are actually going to make, okay? So if we look back at our data here, if we look back at this, I think it's easiest to start here with the 1 to 1 ratio, okay? So here, if we have 0.012 moles of acetic acid and 0.012 moles of baking soda, we would then theoretically produce 0.012 moles of carbon dioxide, okay? If we are looking at one of these where we do not have a 1 to 1 ratio, so here we have 0.036 moles of acetic acid, 0.012 moles of baking soda. Okay, so if I put this in this setup here, rearrange some things. Okay, so moles of acetic acid, I have 0.036. Moles of baking soda, I have 0.012. Okay, so looking here, I think through which one of these is going to be my limiting. I have a 1 to 1 ratio, so that means that baking soda is my limiting. Because baking soda is my limiting, that means that I can only produce 0.012 moles of carbon dioxide. Now the pattern that is here is whatever is the lower amount of moles, that is going to be your limiting, and that is going to dictate what our theoretical yield for carbon dioxide is. This is a unique situation where we have coefficients of 1 for all of the compounds that we are looking at. This is not a super common situation, okay? This is not like how you can assume to be able to find this always, but for this specific lab, it works out that it's pretty easy. So our moles for carbon dioxide here would be 0.012, okay? So for this, think through what is going to be limiting, what is going to be excess. The limiting is how you're going to determine what the theoretical yield is. Okay, let's do one more. I'm going to do this ratio 5 over here. So for ratio 5, I have, for baking soda, I have 0.012. And for acetic acid, I have 0.004. So if I'm looking at these two, I still have my 1-to-1 ratio. So I can see that my acetic acid is going to be limiting. So therefore, the theoretical yields that I'm going to have for carbon dioxide is 0.004. And I can go ahead and fill that in.